Okay, I was asked to do a recording of question 3 from the week 6 AP review, so I'm going to go over that. It says a large university offers STEM internships to women in STEM majors at the university. A woman must be 20 years or older to meet the age requirement for internships, and the table shows the probability distribution of the ages of the women in STEM majors at the university. So part A, suppose one woman is selected at random from the women in STEM majors at the university. What is the probability that the woman selected will not meet the age requirement? So the age requirement is they must be 20 years or older. So I want the probability that they are not, they are not 20, which is, I'm just going to pay attention to then these three discrete probabilities and add those together. So it's just 0.005 plus 0.107 plus 0.111. So add those up in the calculator and that comes out to 0.223, which is our answer. So part B, suppose that a simple random sampling process is used to select the sample of 100 women. What's the probability that at least 30% of the women in the sample will not meet the age requirement? So I'm going to define a random variable here. Let's call it X, and that's just going to represent number of women to not meet the age requirement. All right. So then what they're really asking us for is, what's the probability that at least 30% don't meet the age requirement? So we want the probability that, since it's out of 100 women, 30% out of 100 would just be 30, right? Probability that X is greater than 30. Greater than or equal to 30, I should say. But one thing to know about this setting that we're talking about is that it is binomial. So we can classify each subject as a success or a failure, right? Where success would be meets the age requirement, or no, sorry, got that backwards. Success would be does not meet the age requirement. And we would consider failure meets the age requirement. And then in this case, the probability of success is 0.223. So that's the probability that they do not meet the age requirement. We found that in part A. And then there are a fixed number of trials, right? We are selecting 100 women in our sample, so n is 100. So with that in mind, we can use the Binomcdf command in the calculator to help us calculate this. Now remember that Binomcdf finds probabilities in the other direction. It finds the probability that X is less than or equal to something. So if I want greater than or equal to 30, I'm going to use the complement rule. I'm going to take 1 minus the probability that X is less than or equal to 29. So that's going to be 1 minus, we're going to go binom CDF, and n will be 100, p will be 0.223, and X will be 29. So let's jump to the calculator. So 1 minus, we can find Binomcdf in the distributions menu. All right, 0.223 and 29. And there we go. 0.0453 is our answer. All right, so let's move on to C. Suppose a stratified random sampling design is used to select a sample of 30 women who do not meet the age requirement and a sample of 70 women who do meet the age requirement. Based on the probability distribution, is a woman who does not meet the age requirement more likely, less likely, or equally likely to be selected with a stratified random sample than with a simple random sample? Justify your answer. And so our answer here is going to be more likely, because if they're stratifying and they're selecting 30 women, the probability is 30%. But with a simple random sample, oops. Just realized that I horribly misspelled stratified. Alright, but with a simple random sample, as we saw, the probability was 0.223. So, checks out that it is more likely if we stratify than if we take a simple random sample that we would select a woman who would not meet the age requirement. All right, hope it helps.